Okay, today we are talking about the last section of the chapter, Other Objects in the Solar System. Mostly this is going to be like asteroids and things like that. Sorry. There are your objectives. Locate and describe the asteroid belt. Explain where comets come from and what causes their tails. Differentiate between meteors, meteoroids, and meteorites. And locate and describe the dwarf planets. So, asteroids. They're just small rocky bodies that orbit the sun. They do not have enough gravity to be spherical or to be round. So they just look like big hunks of rock. They have no atmosphere and they have no internal heat. It's kind of the definition of an asteroid. Okay. Asteroid impacts are what we think may have had lots of effects on lots of the planets, even Earth. They may have been linked to some of the mass extinctions on Earth. Some people believe, and scientists are kind of maybe it could have happened, that massive asteroid hits are what caused the dinosaurs' extinction. That is one of the beliefs of what could have happened. Asteroids hit, they sent up enough cloud and dirt into the air that it covered the atmosphere, and so the sun couldn't get in like it should, and caused an ice age, and now we don't have dinosaurs. Area between Mars and Jupiter, that's where most of the asteroids are found. It's called the asteroid belt. And it looks just like big chunks of rock all the way around the whole area. It's not just like one area, but it's all the way around the sun between Mars and Jupiter. They might have become a planet. All this rock may have come together and become a planet, except for Jupiter's gravity kept battling with the sun. You know, the sun's pulling it this way and all of the inner planets are pulling it this way, and Jupiter's going, nope, we're going to go this way. And so it really couldn't come together. So we have an asteroid belt. Maybe. Near Earth asteroids are the ones we are most concerned about. There are over 4,500 asteroids that cross our planet, that cross our orbit. If an asteroid crosses our orbit, it is called a near Earth asteroid. Those asteroids, about one asteroid every year between 5 and 10 meters in diameter. Okay, so it's a pretty big asteroid. It's not huge, but it's a pretty big asteroid. Remember, a meter stick is just 3 inches larger than a yardstick. So it would be about 5.5 yards wide. Yeah, it's a good size asteroid. Okay. Astronomers watch these really closely because those could do some serious damage to Earth if they were actually to hit us. Why are we interested in asteroids? Why have we sent satellites and stuff up to check out asteroids? Because they can represent the early solar system. These are very old, very basic rocks. Also, we believe that some of the bigger ones may contain some very rare materials. that could be useful. So there are actually companies who are wanting to mine some of the asteroids. You getting this? Or are you busy playing with your hair? Because I haven't seen you do any typing. I've seen you play with your hair a lot. Dawn was one of the satellites that actually orbited Vesta. Vesta is a big, huge satellite. I actually orbited it. I'm not satellite, asteroid. For 14 months on its way to another planet. A dwarf planet, actually, but you know. Got some good information about Vesta. So meteoroids, meteors, and meteorites. Basically, they're all rocks. All right? And it all depends on where they are as to what they're called. Meteoroids are in space. So as long as they are outside our atmosphere, they are meteoroids. Once they hit our atmosphere, they are called meteors. So a meteoroid hits our atmosphere, becomes a meteor. When we have bunches of them, it's called a meteor shower. And that's when Earth just goes through a bunch of meteoroids, and they come into our atmosphere, and you see them streaking through. A whole bunch of them. It's really kind of awesome to watch. Meteoroid in space. Meteor in our atmosphere. Meteorite, it's hit the ground. Most meteors are never going to hit the ground. They are going to burn up in our atmosphere. The occasional one that does make it through and hit the ground, it's no longer a meteor, it's a meteorite. We like meteorites because we can study them and learn more about our solar system. That's what anything that comes from space, that's what we do. We study it to find out more about our solar system. Are we good? Comets. Comets are not rocks. Comets are ice. They're balls of ice that have an elliptical orbit around the sun. They come from the outer solar system, either the Kuiper Belt or the Oort cloud, to the inner solar system, and then right back out. We believe that maybe some comets collided with Earth early, and that's what brought water to Earth. Because they're ice. So if they hit Earth, they would have melted and become water. Do we know this for 100% positive? No. But that's what we think happened. Comets will always have a tail, and that tail will always point away from the sun. What happens is the outer layers of the comet melt and start to evaporate as it gets close to the sun. That ice vaporizes and it reflects light from the sun. Why does it always face away from the sun? Because the sun's radiation and the sun's solar winds and all that stuff we talked about the sun pushes those long tails away. Just like if I had a blow dryer and every time somebody came near me with long hair, I took my blow dryer and I pointed it at them. Okay, your hair is going to go out behind you. That's what it does. Always going to point away from the sun. The time between appearances of comets, because they're in an orbit, they have a regular appearance. It's called the comet's period. They can be short periods like Halley's Comet, or some people say Halley's Comet, has a period of 75 years. It will not appear again until 2061. And then it'll come through and it'll streak across the sky and then it'll go back out and we won't see it for another 75 years. Hale-Bopp, on the other hand, was a big deal when it came into view. Its period is 2,533 years. So nobody'd ever seen it before. And it won't come around again until 4,385. A year or two away. Short period comets come from a place called the Kuiper Belt. The Kuiper Belt is just out past Neptune, so it's just outside of our solar system. That's where a lot of asteroids hang out. We have the asteroid belt kind of in the middle of our solar system, and the Kuiper Belt is on the outside of our solar system. It has a bunch of asteroids, it has dwarf planets, and it has comets. But if they have really long periods, that means they have to come from farther away. And those probably come from what is called the Oort cloud. I know, weird name, right? Oort. The Oort cloud is about 50 to 100,000 astronomical units from the sun. So that would be between 50 and 100,000 times 93 million miles. Right? Or 50,000 to 100,000 trips from here to the sun. Dwarf planets. In order to be a planet, just a regular planet, not a dwarf planet, in order to be a planet, you have to meet the following criteria. You have to orbit a star. Okay. You have to be big enough that your own gravity makes you into a sphere. Okay. Makes sense. Right? We got that. Orbit the sun, must be a circle. Okay. You have to be small enough that you're not a star. Well, kind of duh, right? If you're a star, you're a star. And you have to have cleared the area of your orbit of smaller objects. All of our planets do that. Dwarf planets will do the first three. So they orbit a star, they're circular, and they aren't a star themselves. But they don't clear the area of its orbit of anything smaller. In order to be a dwarf planet, you have to orbit a star, duh, have enough mass to be nearly spherical, so be a circle, not have cleared the area around its orbit of smaller objects, and not be a moon. So our moon can't ever be a dwarf planet. Yes? Dwarf plants. Guys, I have checked these like 5 times. And I do that. You don't know how many times I have typed plants. And I caught it every time except that one. Thanks a lot. There, now it's fixed. Right? Now it's fixed. Pluto is the first of the dwarf planets. It is small. It is icy. It is rocky. That was the first thing reason they started thinking that maybe it wasn't really a planet, because, all the other planets, all the other outer planets are gas giants. Well, this is small and rocky. Its orbit is tilted. It doesn't orbit quite in the same elliptical plane that everybody else does. And it has a long, narrow ellipse. It actually is part of the Kuiper Belt. And, remember, to be a planet, you had to have cleared your path. Well, if it's in the Kuiper Belt with all those other asteroids and stuff, it didn't clear its path. But it does have moons. It has 3. The largest one is big enough that they think maybe it might be a double dwarf planet. So the Pluto, it's either Charon or Charon, and I can never remember how it's pronounced, could actually be 2 dwarf planets really close. It has 2 smaller moons, Nix and Hydra. Those are definitely moons. Ceres is the largest object in the asteroid belt. Gravity makes it a sphere. That's good. It's rocky, like Pluto. And it has not cleared its path either. Are we good? Okay. Makemake. I know it looks like make. This is the 3rd largest dwarf planet. It is the 2nd brightest dwarf planet. It is 3/4 of the size of Pluto. It has methane, ethane, and nitrogen ice. Not gases, but ice. And it takes it 310 years to go all the way around the sun. 310 Earth years. I wouldn't even be 4 months old if I lived there. That's crazy. I'd just be a little baby. I'm just saying. You guys wouldn't even be a month old, I don't think. Well, maybe a month. How crazy is that? The largest dwarf planet is Eris. It's 27% more massive than Pluto, and it has one small moon, Dysnomia. Not a lot is known about the dwarf planets, guys, because they're so far out. And last but not least, this is the newest dwarf planet, Haumea. It orbits so fast, it spins so fast on its axis that it actually distorts the sphere, and it's kind of making it elongated. So some scientists are saying if it's not a sphere, it can't be a dwarf planet. So it just got made a dwarf planet, and they're already saying it may be disqualified from being a dwarf planet because it's not a sphere. Weird. It does have 2 moons. Hyakka, I don't know whether that's right or not, and Namaka. Questions? Check and make sure you have all blanks filled in. I say that every day, and you guys...
The last dwarf planet.
That one?
Oh, the last dwarf planet.
Oh, the last title that's dwarf planets. That one.